Hello, this is Module 7 and Investigation 5 is about using the sine and cosine function in applied setting. Okay, so we will do number 2 and 3 and number 6 for ADE. So, but when we do the number 2, we need to talk about the problem, okay? So we're gonna kind of talk about this. Jose extended his arm straight out, holding a 2.3 foot string with a ball on the end. He twirled the ball around in a circle with his hand at the center, and so that the plane in which it is twirling is perpendicular to the ground. Assume that the ball twirls counterclockwise, starting at the 3 o'clock position. So I want to say that it's a twirling kind of this way, isn't it? This way. It's kind of circles around here. So you can kind of imagine this, okay? So define the formula of the function f relates the ball vertical distance above this. The vertical distance it's about sine theta. Sorry, sine theta. So above the horizontal hand in feet as a function of the angle rotating is measured in radian as the ball touring towards counterclockwise from 3 o'clock positions. So we need to find out the function f. Okay, so function f, which is a function theta, but when you have the whatever the function, the sine theta is about sine theta as a functions, okay, which is it's gonna be r times. Okay, so you always have the radius actually the change of the value of the y, right? Okay, but the angle stays the same. Okay, so but this time r is a string, right? Length of string, so 2.3 and sine theta. Okay, and then number 3. Hold it toward the ball so that it travels 1 radian length per second. So 1 radian by the 1 second, okay? Which means, A, what is the measure of the angle of the rotation theta after t second? So we can say that the theta is the same as, 1 theta is the same as 1 second. So what we can do in B, define the function g, but in this time, we're using the time. The vertical distance of the Jose's hand as a function of the number of the second this time is a t, which means instead of the theta, we can replace the t. And C, over what time interval does the ball complete the revolution? So the 1 revolution takes the 2 pi radian, right? But the radian same as time, so you can say that the ball completes 1 revolution, which is a 1 complete cycle, in 2 pi seconds. So about 6.28 seconds, right? Okay. All right, let's go 6. Number 6. Okay, number 6, and let me clear these pages. Okay. All right, number 6. Graph the functions determined in exercise 3 to 5. One each graph illustrate an interval of the input values over the which function value complete the 1 full cycle, which is 1 revolution. So complete the table. So we'll do A here, and then I'm skipping those. Okay, so and then I'm going to do D and E. Okay, we want to talk about some in here. So now you need to fill the table. So G of T was 2.3. Right? It's a 2.3 sine t, isn't it? So t is represent the second, okay? So 0 seconds, so plug it in. 2.3 sine times 0, which come out as a 0. 2.3 times sine pi over 2 become 2.3 pi 0, negative 2.3, 0. You can use calculator 2.3 as a 0. And then negative 2.3 and then 0. Okay, so it repeats it. So on the horizontal axis, which is a time t this time, and then this is sine t. So I want to put every 3, I want to make the pi over 2. So pi over 2, pi, 3 pi over 2, 2 pi, and 5 pi over 2, 3 pi, 7 pi over 2, and 4 pi. The vertical, I want to say it goes up to 2.3, so 1 to 3 is enough. The below you got -1 and then -2 and then this about -3, right? Alright, sorry about the broken plane, okay? Yeah, there's nothing I can do about this. So and the 0, 0, pi over 2 is about 2.3 and then 0 back and then -2.3 is good thing is just right here. And then 0 and then go back 2.3 and then 0, -2.3 and then 0 again. So now make a nice curve. Okay? Don't make the sharp turns. Okay, make a very nicely curvy right here. Okay, now we can answer for the D here. So D is about the describe the reasoning you use to determine the period of the function. So what is a period here? The period means a graph where the graph repeat again. So which is the first graph before the repeating, that's we call the period. So as you notice, graph starting up and down and up, isn't it? But as you notice from after this, do you see that you got the same graph as the first one? So the before the second graph actually that looks the same as the first one. So first graph from the here to here we call the period. So which is every of this period you got the same graph as the first one. So on this one is 0 to 2 pi actually. This is a period. So period is actually we only talking about the one complete cycle. So on this side we can say it's a 2 pi. And the E, what is the amplitude of the function in parts A through the C? Okay, so but we are only using the A. So in this time, the amplitude means you need to have a middle. You need to cut the graph right in the middle. Okay, and then how much it go up or from the middle, how much it went down. Distance of the up and down, this is going to be the amplitude. So for the here, go up to 2.3 and then down to -2.3. But amplitude is always a positive number. Okay, so you need to put the amplitude is a positive number. So it could be 2.3 or it could be -2.3. But comma is always 2.3, okay? Yeah, so that's amplitude. Alrighty. I think that'll be all. Thank you for listening.